Welcome to Luca and Miguel. Enjoy the video.
You begin by securing quality data and a runnable model quickly. First, curate 10K 100K representative samples and deduplicate obvious noise. This cuts training waste. Then pick a small transformer backbone so you can iterate fast. Once done, wire tokenization and sharded storage into a training pipeline and enable mixed precision to save GPU memory. Make sure to log dataset splits and initial model sanity checks. These first steps let you move to optimization without rework. Now focus on stable training and evidence-based tweaks. You should run Atom W with a short warm-up and cosine decay. Tune batch size via gradient accumulation if GPUs are limited. Save frequent checkpoints and enable restartability so interrupted runs aren't lost. Once in progress, monitor loss curves, perplexity, and a few downstream tasks to detect mode collapse or overfitting. Make sure to adjust weight decay and learning rate by small factors. These controlled changes reveal what actually improves behavior. To finish, run thorough evaluation. Held out benchmarks, adversarial prompts, and fairness scans to surface weaknesses. If results are good, fine-tune or distill into a smaller model and apply pruning or 8-bit quantization for deployment. Once deployed, monitor live feedback and maintain checkpoints for rollback. If things go wrong, inspect common culprits. Data leakage between splits, incorrect learning rate schedules, or tokenization mismatches. Correcting those usually restores expected performance quickly.
Thanks for watching and please subscribe. It's the best investment you'll ever make.